The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Lou Itori today. And Dane Dupont is with us behind the scenes. Today is Thursday, May 9th, 2024. And Dane is a little under the weather today, so he's in the back end. So we got Lou today here. How you doing, Lou?
Doing good. How you doing? Glad to take the seat for Mr. Dane Dupont there, 11 shades of green. So.
Yeah. Poor Dane, yeah, but he's here with us behind the scenes. Mahalo for your help behind the scenes, Dane. And Kilauea has continued to be quaking. Right? We saw a series of earthquakes come through last week. We didn't do a huge update because we had our roundtable discussion with local residents following a 2018 anniversary, 6-year anniversary. So hopefully we're able to catch that. We will, in that case, go not quite so rushed through our update this week on Kilauea. Mauna Loa is a little quiet, and then we'll touch briefly on the other anniversary coming up now, which is the 1924 May explosive eruptions of Kilauea. That whole phase of eruption went on for several weeks, but there was quite a lot of buildup to it as well. So today we're going to discuss the buildup. We'll leave next week for the actual explosive eruptions. And Lou and Dane and I are working on something behind the scenes for you guys for next week, something a little different that will complement that and also complement what we have coming up on Tuesday in a national park, which is Don Swanson and Ben Gaddis talking about the 24 events as well. Anything to add to that, Lou?
No, you hit it. I was spending all day on the 1924 eruption, and it's going to be pretty good. A lot of things I'd never seen before, and like next week, nice little touch with After Dark in the Park with Don Swanson. So you hit it.
Right on, yeah. So Lou and Dane will be answering questions in the chat, leading a discussion there, collecting some questions for discussion as we go, as appropriate here. Otherwise, nothing else to add, Lou. We'll get into our summary and get things rolling here.
Let's do it.
All right, so let me switch our screen around. And I should also note, mahalo to Dano and Kiri. Our ASL interpreters are back with us again this week. We appreciate them. We miss them. Glad to have them back. All right, so let's switch our screen around now and get ready to do our Hawaiian volcano summary. So in Hawaiian volcano summary this week, earthquakes on Kilauea have picked back up. After a pause over the weekend, they slowed down significantly there, didn't stop completely, but since Monday have resumed again at these 200 to 300 earthquakes a day levels. It's a little bit lower than the previous week where there were 300 or 400 earthquakes per day, but still this is flaring up in the same area, the upper east rift connector of Kilauea and the south caldera region. And here is a map of earthquakes for the past week that is colored by depth. And let's zoom it in here. So what you can see is this extension off of the main caldera here to the southeast. This is the upper east rift zone connector, sometimes just called the upper east rift. And in the south caldera area is this cluster that's just separate to the side right over here. So those are the two areas that are experiencing the most earthquakes right now. And that's because of intrusion of magma into this whole area from the summit, which is getting very pressurized. The USGS released an annotated satellite map showing the change in elevation over a 2-week period from mid-April to early May. And the long and short of it is that the inflation is centered south of the caldera and southeast in this Koaʻe area. That's west of the upper east rift zone. And likely all this pressurization in here is what's pushing to cause these earthquakes on the upper east rift here. The total uplift measured by satellite is in excess of 4 inches, 11 centimeters. So the ground has been rising fairly quickly over the last 2 weeks in here. And if we look at our sandhill tilt meter, this green line shows that south caldera component. And you can see here it's been rising steadily for all month, but that rate of ground tilt really picked up last week and is still continuing fairly high even as we speak now. So that's Kilauea. She's still pressurized. She still has room to stretch potentially. So we'll just wait and see what comes next there. As for Mauna Loa, earthquakes are very slow. This is the whole last month around Mauna Loa summit. And you see essentially background activity plotted with the small little dots across the board there. Maybe more useful is to look at this last year plot of depth versus time. And all the earthquakes we're seeing now were all the ones in here. So all shallower and not at very high rates. But what's interesting in Mauna Loa is that over the last year, we've seen some of the deeper earthquakes come in a little less than a year ago, peaking with an event in October, November, and a couple of flare-ups deep since then. And so really it's a very quiet period on Mauna Loa where not even the deep activity is happening. All quiet on Mauna Loa, Kilauea is still quaking, and we'll wait see what comes next. And that's our Hawaiian volcano summary for this week. So let's turn now to our volcanic hazards, which are the gas and air quality here. So a national park page has been updated to note the closure of the Jagger Museum building and the monitors that were there. Even still, all the charts are showing everything in the green, despite some outages of signals across the board here. So the volcano is putting out still a little bit of gas, but the background for what's normal on Kilauea. There's a map view of that area all in green. And to dig into that a little more, first I want to just mention that we've been in the past relying on a VOG measurement and prediction project, the VMAP project out of University of Hawaii Manoa. And they have been migrating their forecast to a new computer system, and they have actually started to come back online. So I'm not sure how finished this is, but this is something to point out that may be available soon as a resource. They do note, thank you for your patience as we transition our service to a new compute cluster. We apologize for possible interruptions during this transition. That's what it says up here. So even with that, we can see the source of gas here at Kilauea, putting out very low levels and a little bit of this orange color affecting nearby areas, depending on the wind direction. We have a weather system coming onto Hawaii Island and the state of Hawaii in the next few days here. So there may be some variable winds that may bring smells to places where they're not typically seen. Along these lines, we have seen reports in our comments from videos last week that there are gases still escaping in areas down in the lower East Rift. That's something we hear just about every month, every year. All the monitoring signals are not showing anything as far as magma down there. There is a remnant magma from before, from a 2018 eruption, that still sits underground. And especially when it rains a lot, which it has really been over the last month, with not that many breaks, all that water can percolate into the ground, work its way laterally towards that heat, and then come out days or weeks later as extra gas. And typically it's more of a hydrogen sulfide, more of the rotten egg smell, rather than the SO2, which is the burnt match smell, although you sometimes can get a little bit of both there. So all the monitoring signals are not showing anything happening in the lower East Rift. The gas is only coming out of the summit. Just wanted to add that extra bit in here since we have been kind of speeding through last week and did want to address our community concerns. Something we hear about quite a bit, and usually it's the same answer. It's just the rain coming in and causing more of a visual effect or more of a sensory effect. That's something you can smell. So looking at the data for gas on Kilauea, this is the plot for the last month. So our most recent measurement was 62 tons per day about a week ago. Prior to that, 50. So it's in that ballpark of, call it less than 100. That's the background for Kilauea. However, those levels are still enough that if there was an industrial factory, it would be in breach of EPA regulations. So even though we, on our update here, discount them as background and nothing really that unusual, if you're a sensitive individual when you're in these areas that have gas blowing through, it could be a concern. So you certainly want to follow the park guidance, as that's the most likely area to be affected, and nearby in Volcano Village as well. So that's the integrated measurement. What they do is they go out with their instruments and they try to measure the entire gas column and then integrate with the wind speed to get a full volume. But there also are several stations that just measure ambient concentration scattered around a crater. So here's 3 for the last month. This is Cone Peak, Sand Hill, and down here, I'm not sure PKE, what that abbreviation is. But what you can see over the course of this is measuring in parts per million, is that there's quite a lot of different spikes going on here. Sometimes the spikes are high. Here's one from about a month ago. Here's one just in the last few days. They're about the same size. And a lot of times that depends on the wind direction and the wind actually blowing the gas over this particular sensor, which is fixed in the ground and doesn't move. So it's worth looking at these because sometimes you'll see a signal like a background rate. I like to look at the bottom of the graph and see where that goes. So is it coming up maybe a little bit? Maybe so, but you can see it's done that kind of thing before. So it hasn't done so abnormally out of the previous range when we look at the gas. And the reason I bring this up is because Sand Hill looks normal, but we come back up to the Cone Peak station here and there's something funny going on with this station. And comparing to other stations and other signals, my current leaning is this is likely an instrument malfunction or something like that. Something came and bumped the instrument, or the instrument somehow settled in some way, such that there is a little bit of offset from the baseline happening right there. Now you're seeing a slow climb upwards. So Cone Peak is in that upper southwest rift zone. I wonder if maybe something actually did happen. Maybe there's a crack and it's leaking out some extra gas. But this signal right here makes it super suspect. And so I would imagine we'd see some correction to this, or USGS coming in, maintaining this instrument or something along those lines. And by itself, one off signal without anything to support it. Otherwise, here, or international park data or USGS data, likely this is an instrumentation issue here, in case anyone's watching this closely out there, all the gas signals. So that's the volcanic hazards. And we'll turn to our observations on Kilauea now, starting with a quick peek into the crater. See fume coming off of that inner crust, some water on the lens. You can see some rain actively falling across the view here. And that's our live look into Kilauea now. I thought what we would do now is we would switch over and show you guys a brief less than 2-minute video from the national park that they released to commemorate the 6 years since the 2018 events began. So this is going to recap all the events since then in the previous 5.5, 6 years. And let's check that out now here.
In 2018, the floor of Ka'luapele, the summit caldera of Kilauea volcano, collapsed incrementally over about 3 months. The deepest part of Kilauea caldera, Halemaumau crater, lowered by more than 1,600 feet, with its base deeper than the surrounding water table. In the year after the 2018 collapse, a water lake began to rise from the bottom. It evaporated during about 90 minutes when an eruption started in Halemaumau crater on the night of December 20th, 2020. This eruption was the first of several that have slowly refilled the caldera following its collapse in 2018. 4 other eruptions have occurred at the summit of Kilauea since then, varying in duration from about a week to over a year. Lava fountaining from vents has flowed on the surface, creating lava lakes and paving 500 acres of the caldera floor with new rock. Over 1,300 feet of new lava has been added to the bottom of Halemaumau crater, which is the home of Pele, the native Hawaiian elemental force associated with the creation of new land. Eruptions at Kilauea's summit since 2018 have filled about a quarter of the volume that the caldera collapsed in 2018. While these changes at the summit of Kilauea appear dramatic, occurring over just a handful of years, they're part of a pattern of caldera subsidence and refilling that has been observed over the past several centuries. The USGS Hawaiian Volcano Observatory monitors Kilauea and other active volcanoes in Hawaii, conducting research to better understand volcanic processes and hazards, and keeping the public informed of volcanic activity.
All right, so that's a nice little recap from the USGS on the last 5.5 years there. Maybe a little fast in the middle there, but I guess it is what it is. So we can look at some of the more recent updates from the USGS. They do have a release from last week that they were updating or maintaining their web camera. So here is the field technician looking at their digital displays there and configuring this webcam that's right over here. So pull this back for you guys. Routine maintenance on the V1 camera. This is from the release from May 1st from the USGS here. There's a few other images here. So this is what that looks like. Oh, hold on, I've got the wrong screen, don't I? Let's put this back here. All right, so okay, there is our USGS release and our first camera here. There is a field technician checking out the digital displays. The box is open with the data equipment underneath the solar panel right here. You know, wires leading to the pan tilt zoom camera back in here. Right. So there's a close-up of the pan tilt zoom. And you can move that camera around within that little bubble and look at different parts of the crater, since now there's a lot of different areas that are in play for potential eruption around Kilauea summit. And there's a view looking from that position down at that crested crater floor. You see massive amounts of mineralization, all the sulfur minerals, gypsum, those kind of things that are accumulating around where the cracks of gas are releasing from lava's cooling underneath all of this here still. And one last image here, panned over further to the west. We can look at the cone from last year's June eruption that settled into this spot on the southwest crater wall there. So big feature within an even bigger crater, and just nice to see a different view of it there. Looking a little closely, looks like maybe there's been a little bit of collapse right there in the cone, as you might expect with lots of earthquakes and not a whole lot of anything else happening within here. So those are the visuals for Kilauea this week. And with that, we will switch to our monitoring signals. So let's put those on here and start off with a USGS update for today. As a reminder, the USGS is now doing daily updates. I'm not going to go through any other days except today because it's basically a good enough summary for us here. So there is no eruption. Unrest continues beneath the upper East Rift Zone and the summit caldera south of Halemaumau. They're noting daily counts of earthquakes. Yesterday was 190. The previous day was a little bit more. And they're noting that the depths are between 2 and 4 kilometers, with magnitudes mostly below magnitude 2. So that's really the story. It's mostly earthquakes, but then also ground deformation, which continues beneath Halemaumau and the South Caldera region, both. So they talked about in this update and the information statement they released last week that both summit reservoir areas, the South Caldera and that Koaʻe zone to the Upper East Rift connector, both of those are showing inflation. South Caldera, and Halemaumau are both showing inflation there. And that South Caldera one taking more of the pressure and pushing on that Upper East Rift connector to cause a lot of these earthquakes here. So there is our SO2 rate reported, 62 tons per day on May 2nd. This is just what we showed you in the graph. And otherwise, they are noting that there is no significant activity on the East Rift past Pauahi crater. The Southwest Rift is still quiet, and there is no other indication anywhere else in the volcano of anything else to be concerned about. So that's really it for the update for today. It is worth perhaps just revisiting that information statement from last week, since we did it fairly quickly on our summary and then switched to our roundtable discussion for 2018. And I do note in here that there are those 2 calderas that are essentially both filling. They noted more than 1,600 earthquakes at the time. Now this number is over 2,000. So there have been over 2,000 earthquakes in that area since April 27th. Most of the earthquakes have been on an East Rift connector, with a smaller percentage of them being in that South Caldera area right in there. They do note they saw periods of low frequency activity, typical of magma movement in the earthquake signals. So not only are they seeing the rocks breaking from the earth pressurizing, but also the signals of fluid flow through the rock as well. Okay. So it's going somewhere, and as long as it's going somewhere, there's got to be space for it to go. And in that case, that buys it time until it has to be forced up and out at some later point if it keeps building and pressurizing and eventually runs out of room. So that's where we are in the sequence of things. One other thing that was notable last week that we touched over quickly, but is worth restating, is that they noted that the intrusion in late January, early February 2024, that had drained, they reported 30 million cubic meters of magma from the summit reservoir system. That, or 40 million cubic yards, however you think of it, 40 million cubic yards or 30 million cubic meters, yeah. And what they say is that since that time in early February, so March, April, May, 3 months, we have pressurized back to regain all the magma that was lost during the intrusion. And so they say 2 months of recharge, and that was enough to get it back to its normal levels. I did some math last week, and it actually works out to about the average rate, something like 4 cubic meters per second, maybe a little higher than that. So it could just be the regular inflow of magma is just still very healthy, and it hasn't stopped at all, and it's just building and building and building, and that's what's causing this to go. However, it is noted, I think it was noted, I'm not sure if it's in here perhaps, but they are noting that the magma supply is coming in more of a pulse-like, coming more in pulses than it was before. And perhaps it's something we see reflected with the deep earthquakes we saw last month underneath Kilauea summit, maybe reflecting one of those pulses of magma coming up and in. And now it's come all the way to the near surface and is causing the surface pressurization and the surface earthquakes we're seeing here. I'm not sure I can be able to find that text here, but that is in one of these updates within the last week here. This note that the magma is coming up more in pulses. So that's the USGS text that I'll share. And now we'll look at some graphs. We'll come back up to the top graph of summit tilt here. So this is the Uikahuna station on the northwest rim of Kilauea. And we're seeing over the last 1 week a net inflation. Still some little deflation inflation cycles. There's one, we seem to be in one right now. But overall, the net has been gained. And this is pointing mostly to the Halemaʻamaʻu Reservoir, but it also sees further south across the caldera as well. So earthquakes over the last week. Here is that gap over the weekend, picking back up over the week. You see they peaked 2 days ago and are coming down, but would not be surprised to see these earthquakes cycle through and also flare up in pulse-like fashion. So depth versus time here for the last week. Here is that shallow band of earthquakes coming through, tailing off. There is that relative little gap right there. You can see it starts flaring up. And here is that main pulse that we're at the end of right now. The deeper signal is not showing anything unusual there. This is the Dipahala quakes in blue. And the deeper under the caldera quakes were the ones we saw in yellow. You can see there's still some of those happening, but nothing alarming or really noteworthy, apart from there's still a signal coming from that area deeper under the caldera. So that's the last week, as shown on the map here once again. And we still have the south flank that is still mobile over here. And as this thing keeps moving, eventually it might open up the east rift and allow some of that magma to start feeding its way into that area. And this is going to be a long process, but we may be seeing the beginnings of it here now, and there's still no extra cause for concern for anyone living further down the Middle East or Lower East Rift Zone here. All right, let's go to, there's the cross section. Let's go to the last month. And now at Uikahuna, you can see a little bit more clearly how this last week has been a higher rate of change than the previous 3 before that, even with this deflation-inflation cycle is superimposed on top. This is the one pointing at the Halemaʻamaʻu Reservoir area. And as we mentioned in our summary, the Sand Hill, this green line is the one that points to the South Caldera source, and you can see it also has had that similar pattern. And these values are huge, right? Let's look at the scale here. This is 100 microradians at the top, minus 60 at the bottom. So you can see that over the last month, this Sand Hill component pointing to the South Caldera, and it's gone from negative 40 to positive 80, let's call it to make it easy, at 120 microradians in a month. That's massive. And just in the last week here, we're going from, we'll call it 35 to 85, 50 microradians in a week is also massive, massive tilting going on there. So we might be thinking, is it getting ready to burst out? And it might be if it gets pressurized in the right pockets enough. But as I'll show you in GPS shortly, we still have only come up in total about half of the elevation we lost in 2018 in these areas. So that's why I keep repeating that Kilauea may still have more room to stretch before she's forced to break and erupt to the surface. So looking at the last month, depth versus time, all the shallow stuff really runs together. You can see the gaps a little bit here and here. More interesting is this yellow band showing those deep earthquakes that began underneath the caldera there. And there was another flare up there, another flare up there. And if you're curious about if that was really magma pressure coming up through the volcano, how long does it take? Well, here we are, not quite 3 weeks later, right? And maybe 2 weeks later from the beginning of this pulse here of seeing that effect near the surface through the earthquakes. Doesn't always work out so pretty, and just worth pointing out here in case that one does prove to be a good example. So here's the last month earthquake counts, earthquakes per day, and what we recapped before, between 300 to 400 earlier, and now between 200 and 300. The value yesterday, we were reporting at 190 on Kilauea. So one thing to keep in mind is this count is capturing the entire map that we see up here. Everything in this map area is getting counted in those earthquake bars. So it's better when they report the numbers in the text, and we know that most of these were in that summit region, but not quite all of them. For the last year, earthquakes per week now. Here we are, last week, broke 2,000 earthquakes in a single week across the entire map area. This week looks like it'll be a little slower. What you can see is that those levels of earthquake were not the highest in the last year. That honor goes to the end of January, beginning of February intrusion in the Southwest Rift, which reached over 3,000 earthquakes in a week. But if we compare to the other events, last year we had an eruption in June at Halemaumau, and the buildup of earthquakes never exceeded 1,000 earthquakes per week. There was another eruption in September at Halemaumau, and those earthquakes never exceeded 1,500 earthquakes per week there. Right, and then this whole phase of intrusion into the rift zones, Southwest Rift Zone, began in October. Right, so we've actually are quaking quite a lot. That's not an illusion there, but the configuration of the volcano is a little different now, where it's able to do that without actually signifying pressurization within a smaller area that would cause a surface rupture and an eruption. Right, so we're really involving both the rift zone, upper east rift connectors at this point now in the movement. So there's a larger area that's able to pressurize, and we're seeing effects spread out. And we've seen this pattern since October, working its way into the Koaʻe south from Kilauea caldera. So over the last 5 years, earthquakes per month now. You can see if we had over 2,000 in 1 week, then it was pretty easy to get over 3,000 for 1 month right there. And that follows that slow month gap, right? So really October was the beginning of our Southwest Rift intrusion. We've had high earthquakes really since then. March ended up being a little bit slower, picked back up in April, and now it seems to be taking it up a notch once again. So those are the earthquake counts. And for our GPS, this is north and south across Kilauea caldera. And that distance expands faster when the Halemaumau Reservoir is the primary area being filled. And we've seen that it fills slower, sometimes net zero here, when it's mostly that south caldera area, because the south caldera area is outside of this line measurement, and so it pushes both stations together in the same direction away from where the magma is filling down there. So as that nexus of filling switches from in the caldera to south of the caldera to in the caldera to south of the caldera, you see it go from this expanding more quickly to not so much. And here we see it most recently coming up fairly quickly, showing that within that caldera we're also pressurizing Halemaumau, as well as pressurizing the south caldera, and overall the whole system is very pressurized, which is why that Koaʻe block is moving with so many earthquakes. That's the energy that's doing the work. Further down on the southeast rift at Pu'o'o, our pattern there has been one of contraction. The line's been going down. The distance has been getting less and less and less over time, over the last 2 years. But coming to the very right end here, the signal is looking a little bit funny. It looks like it maybe might be starting to expand a little bit. So we'll investigate this further. One thing to note is we've seen patterns that look a little weird before in the past that just seem to be aberrations, where the regular trend resumed after that noise. Still, with so much change on Kilauea, it's worth taking a closer look at this. So let's go to our 2-year GPS and note that this is a distance between 2 stations, North Pu'u'o Crater and Jacuzzi, NPOC and JCUZ here. So let's go first to our 2-year GPS and find those stations on the East Rift. There they are right there, to show you why that distance might be increasing there. So the first thing to note at both of these stations, one is north of the rift zone, one is south of the rift zone, is an up and down signal. And is the ground rising there anywhere? And if we look at both of these, in fact, what we can see is the ground has actually been sinking faster when that signal is occurring there and there. So that's a good clue that it's not something pushing the ground up in that area. And we look at the other signals, north-south signal, that one's still moving south, that one's still moving south. So what's going on here? Let's look more closely at the east. And we can see there's a little bit of scatter there, but there might be a slight downturn where this station might be moving slightly to the west, whereas this one is still moving a little bit to the east, right there through the noise. So it looks like that increase in distance is not from the stations moving apart across a rift like that, but rather than moving that way apart across a rift to get further away in that direction, which is not indicative of magma injecting into the rift, which is consistent with all the other observations we've seen here. And so not magma going into the rift. And what could possibly be causing that? Let me come back to the map here once again. Scroll it up. There it is. So Pu'u'o Crater is right there on our map. And so one station is there, and the other one is right there. And what's really possibly happening is if we're having movement of this area right in here, and it's pushing east, as clearly indicated by these earthquakes, then it may also be affecting the east-west wiggle of these 2 stations across the rift zone. So likely this seems to be a far field effect, right? Rather than magma coming up underneath Pu'u'o to push it apart, the sides apart. And that's a little bit of a process you might go through when you see a signal that looks a little suspect, like this GPS signal, rather than jumping to a conclusion to say like, oh wow, magma is back in here and let's all watch out. And that is why we do these updates, is to increase public awareness, education, preparedness, eventually the response. And part of that process is just learning how nuanced this data can be. And it's not always black and white. You see it go up, it means one thing, and down the other. In this case, it's our first pass. And if it's going down, nothing to worry about there. Now we go to a little further investigation and see that there's still nothing to be concerned about in the Middle East rift for now. And so looking at what I wanted to do next is look at some other GPS stations, in particular, the ones around this area of uplift. So coming back to the top, the summit stations are not showing anything massively different from what they have in the past. So especially the ones in the north here. When we get to the ones in the south side of the crater at the outlet, the up and down signal you see here is actually rising quite fast. Our scale on the side here is 10 centimeters per box. Right? So it's hard to tell what's exactly weak here, but let's call it this last burst right over here. It's about one of those boxes. So it's about 10 centimeters of uplift in that south caldera area by the outlet right there. Over at crater rim, it's a similar story. Still a 10 centimeter box here, maybe not quite as much uplift, a little bit off to the side, but still rising pretty quickly in those 2 areas right there. And that's mirroring what we saw in the ground tilt. On the southwest rift, don't see much action happening there. Let's scroll by. Let's go to Ahua on the south flank. And Ahua is close to the outlet station, also rising massively. This might be the one that's showing 11 centimeters right in there over the last week, coming up very quickly. and getting pushed to the south faster than before as well. Puhimau, down on the Upper East Rift Connector, Upper East Rift Zone, also rising pretty fast there. And if we keep going, Devil's Throat, also rising fast. And this is following, we saw this was the initial intrusion effect and a rising pattern. There was a little decrease and slower rate of rising until just the last couple of weeks here. So that's showing how the effect is spreading further south. Devil's Throat is one of the further south stations along that Upper East Rift Connector. So the other one I like to look at in the 2-year GPS is this Kalapana Trail, the north-south component. It is still moving south steadily. This is the longest southern southward motion we've seen of this hinge zone of the Middle East Rift Zone for a while. And that's why I've been talking more these days about when magma reoccupies the Middle East Rift, because the blocks of land seem to be moving, rearranging themselves so that eventually that will be possible again. So we'll leave our GPS for the 2-year components at that. You can note the Southwest Rift is stabilized as well. But just to look a little bit more closely at Ahua, this is a 10-year GPS station, or 10-year GPS for Ahua now. So we were just looking at that massive rise of maybe 11 centimeters. That was right in here. That's this little rise at the very end. And I wanted to show this because this comes back to 2018 and the collapse. So this is an area fully outside the caldera, fully outside the collapse zone where things were falling in. This is just the sagging from the edges that occurred, right? And even that was massive. We look here, this is looking at like it's 0.6 meters at the top, very roughly. At the bottom, maybe 0.5, call it 0.4. And so you're looking at 10, a full meter, right, of drop there, about a yard of sagging. And the ground has come up since then from this, call it 0.4, 0.5, up to, well, negative, I should say, up to positive 0.2. So you're looking at half a meter, 0.5 or 0.6 or 0.7 meters in there, which is about half. If you look at that, it's about half of what it's sagged in 2018 over those 3 months. Over the following 5.5 years, it's come up halfway to what it was. Now, maybe it can't all move like it did before. Maybe you can find a pocket of pressurized and burst out without recovering that full amount. But until I see otherwise, my personal leaning is that I believe it when I see it, because it has proven that I could stretch a whole lot more in 2018. Right, so that is the context of this rise, is that it's still only a fraction of what happened in 2018. So if 2018 is any kind of guide, then we still have further to go. Okay, I'll leave that one for the uplift example. And just to come back to the Kalapana Trail, the north-south component, this is the area when magma was erupting out of Pu'o'o, all through here. And so Kalapana Trail moves to the south. This was the adjustment for 2018. It was still open until mid-2021. And since then, it started moving to the north. This was essentially locking, closed that Middle East Rift Zone. And here we are at the very right end of it, where it's finally, for the first time since then, starting to turn around to move back south again. Note that it's moving south at a much slower rate than at any point previous during Pu'o'o era or following 2018 collapse. So also just the hints of it beginning there. That'll be our GPS coverage for today. We do have some InSAR images. And so I mentioned one during our summary. I will start with this one from the Mounts project. This is between April 21st and May 3rd. So it's a different satellite than the one USGS showed, actually. And there's a little arrow up here in this top left corner that's showing the line of sight, the direction of travel of the satellite, and which way its sensor is pointing to get this measurement. So it's actually flying off east of our island and looking to the west to see us. So it's a little bit skewed, and that will, you see why that might matter in a minute here. But what you can see here in this case is a center of inflation, maybe right in there, with concentric bands there and there. That seems like it comes all the way around to here, maybe like that. And an outer one that goes all the way out here off our map, but maybe through there, something like that. So that's the bullseye right in here. And this first image will pass, right? One thing that's really notable is the East Rift connector, Upper East Rift Zone that's right through here. And all of this action is happening west of there, right, off to the side, showing that the earthquakes are not necessarily from the magma injecting directly into the Upper East Rift connector, but rather it's likely filling this whole area, pushing it to the south, where it's able to, like an accordion, crumple back up and rise upwards. Some combination of dynamics, something like that. Another interesting thing here is if you look closely, right under that down drop block area, there's a little bit of subsidence happening right in there. So maybe there's a shallow pocket of magma that's feeding and pressurizing and changing a little bit there too. That's interesting to see. That's the Mounts project. Remember traveling this way, looking off that way. And so now we can flip to the USGS image that was released. Oh, that's the one from before. This one right here, where you see that now the direction of travel is that way, and the direction of look is to the east. So this satellite flew west of the island and was looking from the other direction. It sees an inflation center slightly offset, and this is why the look angle matters. That's something that maybe you could explain away with different satellites across different parts of the island looking from different angles. Maybe they don't quite focus in the same spot. So this one is showing inflation a little bit further to the west by the South Caldera area there. And further, it's showing this distortion of the fringes right through here. See like little gaps there. There's another one right here where you see it kind of get very linear, indicating fault movement. So this is the Koaʻe Fault Zone, showing the faults are actually moving in response to that pressure from the north that's pushing this whole accordion of rock closer together. They have also plotted on in white all the earthquakes over the last 2 weeks. And once again, this is April 19th, May 5th, so very similar time range there. If you note, though, the image looks slightly different. The range change in this one is 1.5 centimeters. So you can count 1, 2, 3, 4, 5, 6 different bands. 6 times 1.55 ends up being close to 11. So that's your total range of ground uplift between out here and the center. And if we come to the one we just showed you guys, this scale is different. This is showing 2.8 centimeters. So you only see 1, 2, 3, 4, which also works out to about 11 centimeters. So it's really showing about the same data, even though it looks different a little bit. So it's cropped in. We don't see the fault movement here. It's a little bit off the image to the south here. So really appreciate when USGS puts out these annotated interferograms, as they're called, which is just a fancy way of saying the satellite's flying over and shooting a radar down, and a radar is measuring distance to the ground, and then they can use that to tell how much the ground has shifted between satellite overflights. So April 19th and May 5th, USGS released a previous one of these, which is there. So in a previous snapshot, the inflation source was certainly more to the southwest there. And you can see there's fewer bands, 1, 2, 3, 4. So about half the amount of uplift. Still significant, but centered more so on that southwest rift connector, South Caldera area right in there. So that's the evolution from last month to this month. Excuse me. All right, so a couple final things. We can look at tilt, reload.
Hey, catch your breath real quick, Phil. take a couple drinks. I'll go through a few things while you catch your breath since I'm up here. HVERI is a registered 501c3 nonprofit, and we could not be possible without all of you, as well as the grants that we have with Puna Strong, as well as the Kilauea Recovery Grant. We appreciate everybody. Dano and Carrie, great to have them back tonight interpreting for us. I'm going to go ahead and say some thank yous while Phil swallows some more water there. We can't have both you guys down. Ken Staggs with $1.99 Aloha Watchers, and as well as a $9.99 super sticker. Thank you very much for the support. Nicholas Werner, let's see, those are questions. A Puna Squirrel with a $10 super sticker. Thank you very much. Appreciate that. Phil, I'll save the questions if you want till later. You can just keep on going if you're ready to move.
All right. All right.
Make sure you guys hit that thumbs up for us, please. It does help. Share us out. Grab that link. If you have any other questions, go ahead and drop them in the stream. Dane is in the background grabbing questions. He's a little green tonight and doing our thing. Thanks.
Thanks, Lou. We'll get that frog out of there.
Yeah, feel better? You all right?
Yeah, I'll make it. Okay. So I wanted to just to show the tilt, just to show that over on the East Rift Zone at Pu'o, we're also still showing deflation there. A couple little bumps, likely a rain affecting the signal here. And Escape Road, which is the station that's kind of at that junction of the summit and Upper East Rift connector. It's a little bit hard to read, but this green signal is the one pointing to the East Rift connector and the blue one towards the summit. And you can see here how there's been net inflation in that region and stabilizing a little bit more so in recent days here. Nothing alarming is a big point of it, right? Our scale is a lot smaller. It's nothing like what's happening over in that South Caldera area. So to me, that seems still the most likely area. If something were to pop out, that's where it's uplifting the most, the center of the bullseye, and elsewhere it's all deflating. Yeah, and Jonica, even further down the Lower East Rift Zone, also showing that same pattern there. All right, so that's the monitoring signals, and we will just show some earthquakes as well. We've been talking all around the earthquakes, but I haven't shown you this version of the map at least. So let's get this up for you. Here is all of Hawaii Island. This is the last 2 days. So colored by depth once again, just to show a little more finely tuned here what the situation is presently. So still some earthquakes happening on the Upper East Rift connector, still going as far south as Hiaka crater near Pu'uhuluhulu, right? And it's getting into that Middle East Rift Zone area where maybe you can start facilitating some interaction there, but we're just looking at the leading edge of this right now. And your other cluster still here in the South Caldera, with today a little bit more action further off down here to the southwest. Right, forgot it does that there. Right, so there's our Koaʻe Fault Zones, and there's the triangle of action for the last month. Now, come and pull this back to do the whole last 2 weeks. You'll see a little more clearly what that triangle looks like. Right in there is that Koaʻe Fault Zone triangle we're seeing over and over again. So looking at this page, which does not like to be inactive, from the main USGS site, now we have the newest earthquakes on board. So the newest earthquake is down here in Pahala. So Pahala earthquake's happening. Still have some background events North Hawaii here and around Hilo. But on this map, which is now colored by time, there was nothing in red within the last couple hours. So it does seem to be slowing down a little bit as well. Right, slowing down while still pressurizing and building up that elevation, right? Maybe that's more of this pulsing effect that we're hearing USGS refer to. So that's really all I was going to add for the earthquakes here, since we've talked about all the signals all around it, and the earthquakes have been the focus of our discussion for weeks and weeks. I thought I would do it a little differently today. And with that, wrap up our Kilauea coverage here. So quickly on Mauna Loa, there is an update for Mauna Loa from the USGS issued on May 2nd, monthly update. And essentially, it's been quiet. Very few earthquakes expected for the post-eruption phase of this volcano. They say magma is still replenishing the reservoir system with a very slight inflationary trend near the summit. Low gas, low temperatures, and there's really nothing else to say than that. The USGS does monitor other volcanoes in Mauna Loa, so they do include here Kīlauea is also normal, Haleakala is also normal, Mauna Kea, normal, and the volcano formerly known as Loihi, offshore, which I'll give it a shot here. Kamaehua Kanaloa is also unassigned, but no significant activity detected. So pretty quiet apart from Kilauea across the island. There are some signals though. Here is the weekly summit tilt of Mauna Loa. So you see a lot of these daily variations. Then some longer variations here, which are not quite clear from this week-long graph. Depth versus time is not showing you much because there's so few earthquakes, only 6 over the last week in that area. And maybe a little more interesting to look at the last month of summit tilt here, right? So we still have our daily variations going up and down. Then maybe there's some other cycle going on here. It's not quite clear. It seems like it's looking a little sinusoidal a little bit there. So I thought right here what I would do is, I like to compare it to some other signals. And today I pulled up the tide chart from Hilo for last month. So here it is. This is what it looks like. And you can see daily variations up and down, larger ones, smaller ones, and an overall envelope that also has a sinusoidal character to it there as well, right? So when we flip back to Mauna Loa, it looks like the tides could be having a significant effect on the signal here, right? So if there is volcano signal in here, it's likely smaller than this tidal signal, and that makes it hard to really see anything. And that's why we can move on from that at this point. Also, we can look at other things like earthquake counts, still very low. Compared to the deep earthquakes within the last year, we're still quite low. Compared to the build up to the eruption in 2022, we're also still quite low. And if we look at the GPS, it's still slowly expanding north and south across Mokua Veoveo, Mauna Loa Summit Caldera. And with a lot of noise, on average, it still seems to be very slowly rising. Right, and there's a lot of noise, as we've been talking about since October, may have something to do with Kilauea's southwest rift having moved so much during that recent phase. So that is Mauna Loa. There are a couple of other things to talk about. Next will be Volcano Watch. Volcano Watch we did not cover last week, but it actually is a recap of that information statement, what was shaking at the summit of Kilauea. So I'll just show you that's where the map for update last week came from. And this essentially recaps much of what was in the information statement from the USGS. So no need to go back into all of that. It is posted for anyone who would like to read it. Volcano Watch this week is now looking at our 1924 anniversary, the blast of the century at Kilauea. And maybe we'll leave the full details of that explosive part of the eruption till next week. But by their definition, the eruption lasted 17 days, killing 1 person and injuring others. So there is an image, enticing little early image of that explosive cloud. And they go into what we're going to talk about today is what happened ahead of time. Most of these stories from 24 pick up with early 2024, where in February in Puna, there was, following a draining of lava at Halema'uma'u, a bunch of earthquakes all the way to Kapoho, massive ground displacement, cracks opening, faults moving, evacuations, but no eruption actually happened there. So that's usually where the story starts. Today, we're going to rewind even further back than that because we're interested in the big picture. One question, if I was living in Kapoho, might be, well, what did it look like in the years leading up to that? What actually set the stage for all that to actually happen, more so than magma withdrawing once in February, because there's more to the story than that. So at this point, I will leave Volcano Watch and let's go into more of a volcano awareness, talking about this 1924 earthquakes and eruptions. So what I've pulled here is a table from professional paper 1806 from the USGS. That's just recapping which eruptions are happening at what point in time. So the big eruption, which was largely steam, steam eruptions are called phreatic. That's the geologic term. If there's magma, it'll be called phreatomagmatic, but really all this means is a steam eruption that they classify from end of April 30th, to the end of May. A little bit ambiguous, the exact dates. So you saw in Volcano Watch, they're calling it 17 days. This count is showing 31 days. So somewhere in the middle there, depending on how you count it. Right, so now I'm gonna go back in time, and what happened in February 24 and through April was earthquake, swarm, and intrusion beneath the Lower East Rift Zone. That's that Kapoho phase. But let's go back further than that to 23, August of 23. There was an East Rift eruption near Makaupuhi. Back to 22, East Rift eruption by Makaupuhi as well. And prior to that was an era of the Southwest Rift. Mauna Iki was active for several months there in 1919, 1920. And so that's what we'll draw the line, right? It was doing stuff in the Southwest Rift. If you make an analog to today, maybe like the intrusion phase, right? It was going in the Southwest Rift. It starts going into the East Rift. How long does it actually take? Well, magma and Halemaumau overtopped the rim in 1921. And as you can see, it really was a year later, the first East Rift eruption and a Middle East Rift. A year after that, another eruption in Middle East Rift. And a year after that, finally, that intrusion to the Lower East Rift and a collapse and explosion to the summit. So for a little more detail, I've pulled out the volcano letter. So this is from April 16th, 1931. They're looking back at the 24 events 7 years later back at that point in time. This is largely Jagger, I believe, authoring these articles. And he shows the state of lava in Halemaumau on June 30th, 1923, where the lava was liquid from cliff to cliff, about 129 feet below the edge. So there's a cliff of the inner Halemaumau pit. There's an upper wall of Kilauea caldera out there. And all this in here is all lava. And you can see the lava lake with some overturning, fresher stuff. It's a little bit brighter gray, and the darker crusted slabs would be this darker gray right through here. So that was a state in June that was prior to the very last, or we'll call it the middle East Rift intrusion and eruption right there. And so let me come back here to highlight some parts of this. They note that May 13th, 1922 was the highest stand of lava, where lava had risen to 49 feet below the rim. And that was before, later in May 22, they actually saw everything drain away and collapse down, so that it had dropped out 300 feet in the 2 weeks in May of 1922. We're still 2 years before this, right? We talk about how there were lots of earthquakes, avalanches from the walls, roars that people heard. It sent up cauliflower clouds of dust as these collapses were happening off of Halemaumau. The pit enlarged from a maximum diameter of 1,400 feet to 2,000 by 1,500 feet wide. By the end of that month, the lava had dropped down 1,000 feet, and there was rubble 860 feet below the rim of Halemaumau. So back in 22, May 28th, 1922, fountains in Makaupuhi. The eruption didn't last that long, and lava comes back in and refills the pit. So let me scroll down here. They actually have a plot of lava levels in 1923, right? But in 1922, the lava had been quite high, it dropped back down, and was building back up before another intrusion to the East Rift caused another drop of lava again. You can see that actually happened in 23 again, and then the final one's going to happen in early 1924, which is the start of that pre-explosion sequence that we saw in Volcano Watch. So really, there were 3 different drops of lava and summit collapse, small subsidence at Halemaumau that showed magma moving to the East Rift 3 different times, a year apart, prior to all these explosions actually happening. So that 23 event was a similar pattern. June 2023, the lava was very high, as you saw in an image up here. This one. Lava level drops all the way out, and at Makapui, August 25th here, they're showing this image of spatter in the trees. You see sulfur discoloring the ground, and there are some pads of lava here around that are hard to make out from this black and white image, but this is west of Makapui. So they note that in 1923, let's see if I can find it here. They do note that the lava column was pulsating as it dropped down, and then pulsating as it comes up. It's not coming up steady; it's kind of coming up, but still varying, wiggling its way up and wiggling its way down. So on August 24th, 1923, the lava was only 220 feet down, but as the lava drained to feed another East Rift eruption, it ended up being down 564 feet down, a tumbled mass of broken blocks. Okay. So that was the buildup there, and the final event would be in 1924. So by January 24, lava's come back and refilled the crater once again, and then you have collapse in February, March that leaves a 400-foot hole with a glow out of the bottom of it. So what you're really seeing is that pulse of intrusion into the East Rift. So you'd see, to put the comparison back to today, before we see something in the Lower East Rift occur, we're likely going to see intrusion into the Middle East Rift multiple times, eruptions out of the Middle East Rift, propagation of signals down the rift, until eventually someday the Lower East Rift becomes active again. So that's the lead up to it. We'll pick up next week with April, with this very last intrusion in the Kapoho, the effects on the ground, and go from there. But this a little bit of the prequel to the 24 earthquakes and eruptions. One thing to note is that the biggest explosion of that occurred on May 18th, 1924. The one person killed was a photographer whose name was Truman Taylor. Now, interestingly, 56 years later, also on May 18th, 1980 now, was when Mount St. Helens erupted. And both eruptions killed a man named Truman. Truth is sometimes stranger than fiction.
How is that even possible? Right? I mean, that's too coincidental.
Yeah. And not in a volcano watch this week, but I've got a friend who is an archaeologist here at the national park. Before the collapse in 2018, they went out to the site and actually found the frames of his glasses still lying in the ground. So they recovered those. And so hopefully someday we can tell that story a little more. Just in the nick of time, that area collapsed into the crater in 2018. And it's now just documented through what's left. So that's our little peek into 24 and preview for next week. It is worth going to our community corner now. And starting with events in May, there's a famous image of the group of visitors in front of Volcano House with the explosion plume behind them. We'll revisit this next week, a slightly different take of it. But what's worth noting here is Tuesday, May 14th, 7 p.m., Kilauea Visitor Center, After Dark in the Park talk, 16 explosive days at Kilauea in May of 1924. So focus on the explosive phase of that eruption as well. This will be Don Swanson and Ben Gaddis. Ben Gaddis is a volunteer retired judge from Hilo. He's been a volunteer for USGS for many, many years and done talks with Don before. So that is coming up next week. We will be streaming that for you guys to bring you that content as well before we come back with our update next week to wrap up the story there. So that's May 14th. And then following Saturday, May 18th, which will be after our next update, but just to share with you guys, there will be an encore performance of Nani o Kahuku Living History Play. This is going to be set at Kahuku Ranch, where the diary was actually written. And we have plans to film this. This will not be something we broadcast live because the reception is terrible out there. But eventually we'll edit it out and bring it to you guys at some point in the future. So that's the near future horizon of our community corner here, highlighted by this 1924 event, especially there. Right, and one thing that's interesting that may be worth highlighting that we'll get to is until 2018, we thought 1924 was pretty simple to explain, with magma leaving the part underneath the volcano, groundwater coming in, and groundwater leading to the steam explosions that occurred for those 16, 17 days. They're hinting that groundwater models now suggest it would take many weeks or months for the water to flow in there. So maybe that wasn't quite it. Maybe there's some gas component to this story as well. The magma had to have a certain kind of gas content, or we'll see. This will be out in Volcano Watch next week, as well as covered in the talk by Ben and Don. Okay, so 2018 did not cause those explosions, but it did cause plenty of collapse, for which there are still closures and delays at the national park. This is not news if you've been following us, but we do have high visitation months coming up in June, July, and August, which combined with construction will require additional planning for anyone wanting to come and visit. So recap on screen here: Uikahuna area, Crater Rim Drive, the visitor center, the park entrance, and off on Mauna Loa, the Tree Molds Road are the closures currently in effect. One thing that has been reopened is the Train of Craters Road and all the other sites. They have been closed following the seismic swarm at the end of last week. So in last week's update, we may have mentioned the closures, but on Monday, after that weekend gap and earthquakes, everything was reopened, as you see here. So great to the park to be nimble and reopen things as quickly as possible. So that's the park updates. We have a couple other community things to mention. One is just that we at HVERI have been hosting an intern, David Mazer, for this past semester. He's been doing our shorts and summaries for Instagram and helping us out with that as well. And that has come to a close. There is an article here at Hilo showing that partnership between us and He got semester credit for this. He got a stipend for this as well, and helped us put out these systems where we can put out more content, better summaries, and better address our audience, so that everyone out there can get some volcano information in different formats as is appropriate for their ability to look at it, right? Sometimes you have more time, sometimes you got less time, sometimes you want to read it, sometimes you want to see it play as a video. So trying to cover all our bases, and David was a big part of all that. So mahalo to him, very much so. And you can see he also is being recognized as a commencement speaker at Hilo's graduation this weekend. So congratulations to David once again. And this was worth noting, a joint program with Big Island Press Club as well. They're the ones who made this fully possible for us. They allowed us to host this intern before we had finalized our nonprofit standing. So without Big Island Press Club, this would not be possible at all. So a huge mahalo to them. We went to they came to us and asked us, how can we possibly help you? And we said, well, we're working all the time. There's so little time to do all the stuff we need to do. We could use some help, but we can't hire an intern because we're not an organization yet that can do so. And they said, well, what if we do it for you? And really amazing. We really appreciate those guys. Big Island Press Club. So, and David as well. So all that as a success. The final community item today is an announcement from Paradise Helicopters. Paradise Helicopters are no longer taking new tours, charters, or utilities bookings at this time. And if I zoom into it here, company news, end of an era. Paradise Helicopters is shutting down operations. Calvin and Stacy Dorn are retiring after 25 years. And this is noteworthy to us because Paradise Helicopters has supported many of our eruption efforts. They were supporting the community in 2014 and 15 during the Pahoa lava crisis, in 2018 as well, in 2022 for Mauna Loa, often in partnership with our friend Andrew Hara. This is amazing photographs. In 2018, it was even further than that. They were rescuing cattle, bringing provisions to people in the isolated zone. There's an area that was cut off. There was no way out of there since the lava had cut off the roads out of every direction. So they'd bring supplies to people, take out trapped cats. That's just a little bit of the work that they've done. They helped on Lahaina. They helped on Oahu. They put out a little video. I'll play for you guys here as I continue talking here of their operations here. So mahalo to Paradise Helicopters. That's a 2018 eruption there. They very quickly often deploy. They deployed to Halema'uma'u last year in June. We're the second helicopter on the scene with Andrew on board. Here they are on Oahu lifting equipment on the top of buildings, taking away a non-functioning helicopter there. There's Cal, who for many years worked with Bruce Amori and Mick Calber as well, bringing information to people. And yeah, that's where they are there. Let me see if I can pull up. There was one other video that I didn't have lined up. Maybe I won't show the whole thing, but there is. Let's see if it'll pop up here. Yeah. Here they are, a couple of cinder pits and staging. And let's see if I get the right spot. Here they are. He's actually got this net. He's hanging from the helicopter. And there he is, scooping up a cow and then rescuing it, right? So I think over the course of several days of doing this, they rescued over 20 animals, 20 or 30 animals, cows, sheep. And apart from this operation, we're also flying out cats fairly regularly that were being trapped in that isolated zone, right? Trapped with food and water and then taken out of there to safe places, rehomed. So shout out to those guys. I know that they are a business, but it seemed appropriate to honor them here since they've contributed to our community efforts for many, many years. Aloha to Paradise Helicopters. Okay, that's the community corner. We can say some thank yous, and there's only one last thing to throw in here, Lou, which is there is a 5-minute video that Puna Strong, Hawaii County Kilauea Recovery did about us. But maybe we can say some thank yous and talk about some questions, and we'll play that here in just a minute. Right?
Sure,
and
sounds good.
Put up donations.
Again, thank you everybody that's donated in super chats here. We also take donations at hveri.org/donate. It's the best way to send us a donation. That way we get the most out of it. Again, thank you to Puna Strong, Kilauea Recovery Grant. We can't function without all of you. Thank you. Also to Carrie and Dano doing all this for us. We appreciate that. I have some questions. Do you want to wait till after the video for those questions?
Yeah, maybe so. Let's just play a video since we just did our thank yous here. And
Yep.
all right, let me get this video on the screen here.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. We are a new nonprofit, even though we're kind of an older organization at this point. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group, we did a whole bunch of things throughout that eruption, and then since then we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption, and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, where we teach people about the volcano processes, what to expect, preparation, hazards, all those things, so that when the next eruption does come, we're better prepared as a community and we have more resources on the ground. And the other part is digital resilience, which we address through online groups on social media, like Hawaii Tracker, but other social media groups as well on Facebook and hopefully beyond that, where we can pass information from officials to the community, but also harvest information from the community and crowdsource what's happening on the ground and feed that back to the authorities so that we can respond faster and have a better result of any disaster impacting us. We saw that information was really helping people guide their decisions of how to prepare, how to evacuate, what to prioritize. And we realized at that point in time that our local communities knew less about the volcanoes than many visitors coming to the islands. So that's when we really chose to pivot education towards our locals so that we could be better prepared to deal with this. And that's how it started.
Yep. There's really two ways that we do our updates. One is in blue skies operations when there's nothing happening, and one is in disaster mode. So 2018 was disaster mode, which means you're getting updates daily, twice daily, sometimes more, right? We're trying to keep up with the situation on the ground, and in a ever-changing environment, sometimes you have to go hour by hour.
Yes, the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well. So in the first few moments of any eruption, it's usually looking at all different data streams that are coming in. We're looking at what officials are putting out in writing, but also at their official cameras, their official data streams, and all of that. And so having worked with them for many years now, we can then offer that first iteration of interpretation and then really help amplify the message that the authorities are putting out.
What we were working for really came about in the Mauna Loa eruption in 2022, because in that eruption, it was completely different from our previous major eruption, which was 2018, because within hours of that eruption starting, we were live already. That was expected. But then we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn, and we had Civil Defense Director Talmadge Magno on the stream to be able to discuss the ongoing situation. We asked some questions, trying to help flush out a little bit of the ongoing, because it's so new and we're trying to figure it all out type of thing. But really that was a great training session all in all, a real world training session that was with a relatively benign eruption in terms of a rift zone eruption from Mauna Loa. We had the training wheels on for this one, and those training wheels produced a lot of things that we can build off of to go towards the next time Mauna Loa wakes up again.
Yeah, every global disaster relief agency prioritizes information as one of their primary sources of aid to people, because it's that important to people's mental health and well-being. It's at some point irrelevant if you're in a safe space, but you're going crazy because you can't understand what's going on, why it's happening to you, how long it might last, what the impacts might be long-term. Information is really one of the most important things for people to process what's happening, to be able to deal with it and move on and not be paralyzed and trying understanding what's happening. I think the biggest thing about Puna Strong that's been revolutionary to us is the pivot in the model of coming to us, and rather than trying to have us change what we're doing to fit into a box, but to amplify the work that we had already determined was necessary through the means that were most effective. That was what really empowered us, was Puna Strong believing in our mission as we had conceived it, and allowing us to invest time in that preparation, which is so important for the disaster's actual effect on communities. So that's really Puna Strong has allowed us to do that, to where we feel like we're in a much better position now than we were at any point in the past, where we have buy-in and collaboration from the county and from the USGS. And if we could generalize more, we see what has happened on Maui with the spread of information, the lack of spread of information, and we feel that the systems we're putting into place now provide a solution for those exact issues. Yeah, we're very thankful for Puna Strong. Without Puna Strong, much of the work that we've done would still be in its infancy, and we would be really fighting an uphill battle and wishing we could make a better impact in our communities, seeing all the challenges that we face.
Yep, it's still an uphill battle, but at least it's not a cliff anymore.
All right, what did you think, Lou?
That was good. You know, one thing I picked up on there that I find interesting, that I think it's lost sometimes in everything that we do, is everybody focuses on the actual area of the eruption and the panic and the people that are involved trying to get away from it or get their families away from it, but they lose sight of those individuals that are not near an eruption, are in a safe place but can't get the information. And that's important, because on the back end, that's what I deal with a lot. I mean, most of the time is answering those questions for those who just need to know what's going on. They're not in immediate danger. They're not trying to evacuate, but they just need the information. That's huge. It's a huge part of what we do.
Yeah, it really is. Yeah, and that was made obvious to us when in 2018 everyone evacuated from Lower Puna and dispersed to Kona, to Kohala, to Hilo, Maui, Oahu, off island, all over the place, and they were still deeply connected to the events happening here.
Right,
they just weren't physically here.
Then what? I'm in Kona, or I'm in LA, and now what? And we already know, most of you all that listen to us, you all know how hard it is to find out what's going on here. Imagine trying to find out what's going on when you really need to know what's going on.
Yeah, let's say you have a family member on an island or a friend, and you know they're in an area that's being affected, and you can't get a hold of them, right? Like, with our information, we tend to make bad decisions, right? And those have consequences, and it's really about that, right? It's always about making the best decisions possible with the best information possible, which we hope to deliver during a disaster, but also now in advance to prepare everyone so that it's not such a uphill battle when we get to that actual response time, right? We'll have, as we've said before, our whole army of all our viewers who are really being educated ahead of time that can help us share this message and help explain to people how things work and what's going on and what's normal and what's not normal, and what's the appropriate level of response to any particular event.
Right, and I think that the army that has surrounded us to assist us has been a pivotal point, has been one of the biggest impacts, because when we put out the word on something, it goes like wildfire. And I see that coming back when I start seeing the questions slow down on my end, or I start hearing people asking different questions. That's when I know the message that we put out got out there, and we couldn't get the message out without everybody. There's just no way. And now you brought up our intern, doing work for us, all the different social media platforms that we need to participate in it's a basket full. So having the intern program with HVERI really is important to us, and because there's a lot of work to do, and there's a lot of different platforms to hit. I mean, we spend a lot of time on it.
Yeah, for sure. So, do you want to get to some questions and discussion here before we wrap it up?
Absolutely. Let me jump in here. All right. First one I want to throw out there is from Yvonne. Yvonne also donated $50. I want to say thank you very much to Yvonne over at our hveri.org/donor box.
Donate.
Or donate, thank you. I was reading at the same time. Sorry about that. HVERI.org/donate. Thank you, Yvonne. She asks, I wonder how precise the InSAR images are. It's pretty forested in that area and could produce some errors.
Yeah, that's a great point. There are ways to filter your data, right, to see like what data is actually coherent and what isn't coherent. And areas that have tree cover are not so coherent. And what really helps that area have any kind of coverage is that 74 flow that goes south and cuts through that forest just west of the Chain of Craters Road. That's what gives you that extra bit of resolution. Let me see if I can pull that image up again just to point that out. It's one of these many ones. You can see it easier on this image here. So let's put that on stage. There we go. Right here, you see all this speckled fuzzy stuff. That's all where the trees are, everywhere here on the east side of Kilauea. But this zone right here, like that's the lava flow that goes south. And so that, it actually goes like this all the way to here, like this, like that, right? So that gives you a little bit of resolution in there. And yeah, and so there are different ways to filter through this, and that may be another reason why you might see a little bit of difference between this particular plot and that one. This one, the earthquakes make it hard to see that lava flow right in there, but it can be very challenging, right? This is why in the lower east rift area where it's much more forested, it's hard to get this kind of information. And when it's in the southwest rift in the desert, it's really easy and obvious. And that's just the first layer of complications. If you have weather, atmospheric conditions, that can add another wrench in your gears, but I'll just leave that at that, right? And yeah, that's how I'm on. So there is a lot of imprecision, we'll call it, right? Of exactly where is it slightly more west, slightly more east. There's a look angle. There's how you filter the data. It might be affected by the trees or by the atmosphere. But overall, it's still better than having to go out there and hold a ruler at every point of this area and try to measure it. And you're probably going to end up with a similar amount of error, depending on how long you take to do it. So that's the benefit of this technique is you have a huge snapshot of a whole area without having to have anything on the ground. And you get it, in this case, every week or 2 weeks or so, right? So it's not as good as having it every hour, every day, but it probably takes more than 2 weeks to conduct a full leveling survey across an area this big anyways. So we'll take it.
Yeah. All right, and Nicholas Werner has a question here. It says, click on here. Does that pop up there? There we go. Can someone explain Kahuku's high SO2 measurements recently?
Not really. I mean, we saw those last week. It seems like the signal came off the plot this week. But what we can say is that with no other stations anywhere between Kilauea or Mauna Loa and Kahuku showing that signal, that it's likely something localized to the area, whether it's an actual SO2 source in Kahuku, near Kahuku, or whether it's an instrument error as well, some kind of instrument where it was putting out abnormally high readings. And the reason I say that is when we looked last week, it looked like it wasn't like the values were fluctuating day to day in the red. They're all the same value, exactly flat, day after day after day of being in the red. So that's my leaning. I haven't heard anything official, but that's the discussion I can offer, and I don't really have a solid answer for you, Nicholas, but it's a good point, and thanks for paying attention.
I got another one from Nicholas. I'm not going to slide the question across because Dano's right there, and it's going to block our deaf community's availability to see him communicating. So I'm just going to read this one out. Do sulfur deposits go from yellow to brown as they age or are exposed to rain and water vapor?
I don't know that they necessarily go to brown. I mean, so water vapor, so these things can dissolve again, actually. So more than likely they like wash away if it rains a lot and then reform, right? And sometimes when you have lava tubes that have big entrances and they have crystals, like, sulfate crystals growing on the ceiling or the walls, what have you. You can tell that during dry periods on the surface and the airflow that moves between a cave and outside, that those crystals will actually grow more. And when it's humid out for long periods of time, like this last month, you'd see them actually dissolve back as well. And so they're constantly going this growing, dissolving, depending on under conditions. So if they're out in the open somewhere where like an actual rain can hit them, then usually the rain will dissolve them and wash them out. Now, there could be other reactions that occur with those minerals that can then form something that maybe is more grungy looking and maybe more brown, something like that. Without seeing something in particular, it's hard to know exactly what, and it might be harder to tell even then, because once you get into the reactions of minerals, they can start forming clays, of which there's many different kinds, and have really complicated chemistries. So it gets messy. So you can get to something that's brownish, right? But I hesitate to say it's directly just the aging of the sulfur. Something else has to be present and to cause a reaction, right? And if it's just rain, you'd suspect it to be washed or dissolved away. I'm not a gas expert. I'm not like a mineralogist either, right? But that's the take that I can offer for the discussion here.
All right. And this is a question that comes up quite often. The Dutchman's Woodchuck asks, is the lava pool still active in the crater?
At the surface, no. It's completely crusted over, but that's where the gas is coming from. The gas is coming from the magma lava that's still in the core of that donut that's still gooey on the inside and not hardened all the way. See, it's hardened on the top and on the sides and on the bottom, and some part of the middle is not all the way solid yet, right? And from there, you can still have gas movement and degassing, and that's where the gas is coming from. So if you were to drill into that pit at the summit, you'd come across fresh lava at some point. It'd be really interesting to know how far down, but we're probably not going to discover that, anytime soon. But there is lava / magma still in there. I say it that way because if underground it's still magma, if it's on the surface it's still lava. If it emerges into the bottom of a lava pool, it doesn't actually take a gasp of air. Which one is it? And I really don't care, and I just put a / in between and let someone else argue that one way or the other. But the terminology is not live or die for me, right? It's more about the process and how things happen. It's more important to understand and what term we call it, for our audience at least.
Right.
Don't try this in college. Right.
Yep. Well, that about does it for our questions. Let me just remind everybody, please make sure you've hit that thumbs up, grab the link, share it out with somebody. Everyone makes a difference, helps boost the algorithm for us. And that is all my thank yous. I think I covered everybody. Thank you to everybody that's donated tonight. We appreciate that.
All right. Let's see if I can wrap us up here then. So we will play our outro. Mahalo, everybody, for joining us today. Until next week, unless something else happens between now and then, we'll be back at our usual time, Thursday the 16th, 5 p.m. Hawaiian time. And from HVERI, I'm Philip Ong, Lou Itori, Daniel Kaufman, Kerry Kaufman helped us out earlier. Mahalo, everybody, and until next week, hui ho.